Welcome to this short unit where I want to give you a motivation why it makes sense to actually learn about linear algebra, learn about matrices and where we can use matrices in. Well, one example could be if you want to analyze networks. This could be like social media networks, Instagram, Facebook, stuff like this. But it could also be like networks of friendship or which people you know, or something like this. Could also be trade relations of different countries. So in either case, you need to be able first to represent the network in a mathematical fashion. And that's where so-called adjacency matrices come into play. And that's actually what I want to explain. How can I transfer a network into an adjacency matrix, so make it analyzable? Well, I can construct an adjacency matrix by simply putting a 1 in row I and column j if node I and j are in any relation with each other. So it could be like person I, person j are friends. So then the matrix would have a 1 in row 1 and column j. If there are no friends, I would have a 0 there. So 1 if two actors, two nodes are related, 0 if they're not. Well, this assumes there's only one type of relationship and it's always of the same strength. So if you want to actually measure type or strength of the relation, well, simply replace the 0 and the 1 with a measure giving you a value for the strength or for the type of the relation. However, usually the matrix can only take like a single value, so you can either go with the type of relation, which means only one type per relation, but you cannot have like they are friends and they are colleagues. So this would be a multi-value value case. This cannot easily be represented in a single matrix. Well, if we build an adjacency matrix like this, we can have, for example, undirected or directed networks. An undirected network is something like Facebook. If you're friends with someone, he's automatically friends with you. If you have a network like this, your adjacency matrix will automatically be quadratic and symmetrical. On the other hand, if we have a directed network, like Instagram, if you follow something, this does not necessarily mean that the person follows you back. In those cases where you have a directed network, usually it's not symmetrical and it's not even quadratic. So the style or type of matrix also tells you or directly tells you something about what the network you're analyzing. Well, we can also then differentiate between one-sided and two-sided networks. This basically mean the matrix or the matrix's columns and rows represent the same set of people, that's one-sided networks, or they both represent different sets of people. Like this could be Facebook in general. This could be if you differentiate between normal users and influencers. And you just want to know how those two groups actually are linked with each other. You're not interested in links between influencers or between normal users. You're just interested into links between users and influencers. So usually a two-sided network is part of a larger one-sided network. And accordingly, well, the adjacency matrix of a one-sided network automatically is quadratic because I have the same group in the rows and the columns, so the same number of rows and columns. Whereas for two-sided networks, very rarely is it a quadratic matrix. Well, this means, again, if you know how the adjacency matrix look like, you can directly get your first insights on the nature of the network. So finally, I just have here a short illustration how such an adjacency matrix might look like. This is like a short extract from the network you've seen 2 slides earlier. So that's how this might look like if you put this into Excel.